Okay, so this is the question I left you with the last time, and I hope for part one you did something like this: 0.01 multiplied by 12.5, which is divided by 1000, and then your answer to
Gives us
this one was
1.25 multiplied by 10 to the power of -4.
right, and that is moles. Okay, so I hope you did the next part something like this: HCl ratio is, and HCl was 2, S was 1. This is 1.25 into 10 raised to power 4. Very messy work, but X is 1.25 to 10 raised to power 4 divided by 2, which is probably 6 point
6.25 multiplied by 10 to the power of -5.
negative 5, right? And again, that would be mole. So I guess you use this answer, 6.25 into 10 raised to power -5, and you multiplied it with AR of sulfur, that is 32. So the answer came out to be
2 multiplied by 10 to the power of -3.
2 multiplied by 10 raised to power -3. And it is exactly 2, or are there any decimals connected to it?
Let me do it again. See.
Take your time.
No, sir. It's just 2 multiplied by 10 to the power of -3.
So we're going to do it like this. Okay? And that is grams. Okay, that's why you were having a problem with this part. Well, I gave the wrong value. Yeah, sometimes to my mental math calculation, I tend to give out the wrong value. Well, this time predicted yield is much less and our actual is much more. So this is 1.25 divided by 2.00 into 10 raised to power -3 multiplied by 100. At that time, I was thinking to change this value, which I gave as 1.25 grams. I was thinking to convert it to 1.25 milligrams. If I would have done it that way, it would have been correct. So this must be something really big, right? It's
Yes,
even
sir.
more than 100% answer. So what if I make the change now, and what if instead of 1.25 grams, I convert it into 1.25 milligrams? Okay, let's change the question a little bit and put it 1.25 milligrams. Remember, milligrams means 10 raised to power -3 grams. 1 milligram is equal to 10 raised to power -3 grams. So if that is so, what then?
We'd have to divide. Would have to divide, sir. 10 raised to the power of -3 with
With
1.25.
like this. What
Yes, sir.
is your answer now?
Sir, it's 62.5%.
That's correct. That's something I should have gone with in the first place instead of putting just 1.25 grams.
Yes, sir.
Better. All right. So I hope you understand this question. So I'm gonna stop sharing. So last time when we started off with the 6.5 moles in solution chemistry, we were supposed to do concentration of a solution. And as per this big pink portion, we were supposed to go with mass concentration, molar concentration separately, and to how to convert one type into another. Yeah, we needed to know how to make calculations using solutions. And after doing those calculations, and we have a worked example over here, and this is pretty easy of a worked example. We went with examples like this already. So the next up is acid-base titration. In titration, what we do is that we react an acid with an alkali, and we tend to go with a question like this. So I'm also going to give you a question like this, but let's go with this worked example first, and then we're going to go with the question after. So this worked example 6.10 says a solution of hydrochloric acid is titrated against a thin solution of sodium hydroxide, right? So it is found that 20 cubic centimeter of acid neutralizes 25 cubic centimeter of 0.1 mole per decimeter cube. This is the molar concentration of sodium hydroxide. So what is the concentration of hydrochloric acid solution? So volume and concentration for NaOH is given, but only sorry, seems like flu is on its way. Well, getting back to it. So volume and concentration for NaOH is given, but only volume for the acid sodium hydrochloric acid is given. We need to still find out the concentration. This is what the questions for acid-base titration look like. And you're going to find a few in past papers. So basically what these questions are is that two pieces of information is given for one of the either the acid or the alkali, and only one piece of information is given for the other substance. If two pieces of information are given about the acid, then alkali has only one piece of information and we need to find out the other. And again, we're going to use the same footbridge. Whichever one has both pieces of information, I mean the concentration and the volume, we're going to convert it into moles, just like we did in the question we did right now. And using the help of the equation, we're going to find out the ratio between the both. This is the question in which we take the ratio between both the reactants. It's not a reactant and a product. This is where this question differs. It's about both the reactants. So we take the ratio in between both the reactants, find out the number of moles for the unknown one, and then we go with the same formula to find out its concentration. That's about it. So instead, we were just going with four-step questions. This is actually just a simple footbridge, a three-step question. I hope you get the point, right?
Sir, I'm still kind of confused. Could you repeat it one more time, sir? Possible?
Uh, why don't we take the same question over to the whiteboard and solve it there, step by step? Because if I'm going to go with this book, there are too many word-based lines in the book, which actually takes you away from the mathematical portion. So if we're going to straightforwardly follow only the mathematical part, it might make the whole thing easier for you. So let's just keep in mind that 20 cubic centimeter of acid neutralized 25 cubic centimeter of 0.1 mole per decimeter cube in NaOH, right? So what I'm gonna do is that, right? So let's try to do the same question over here. So question number one for acid-base titration. So I guess we had 20 cubic centimeter of HCl completely titrated against. Titration is something that is a part of actually the second last part of chapter number 5, just the previous chapter. If you go through those videos, you'll understand that too. Okay. So completely titrated against 25 cubic centimeter of 0.1 mole per decimeter cube NaOH, and this is really the reaction. Sometimes the reaction comes as a part of the question, sometimes it is something that you need to write down. Since from chapter 5, it has been a practice for students, so it's usually easier for them to write the equation on their own, because in titration equation, we take the H out of the acid, we take the OH out of the alkali, and we form water with it. Whatever's left with the starting part of the alkali and the last part of the acid is going to form a salt, which is sodium chloride in this case. So find out the concentration of HCl solution. That was the question. Okay. So question would have three parts. Number one, moles of NaOH used. That's going to be the very first part. And number two, moles of HCl reacted. That is going to be our second step. And I hope you remember from a previous practice that first step is usually the formula step, second step is usually the ratio step, and third step is usually the formula step again. So that is in mole per decimeter cube units. All right, first part first. Now we do understand for number of moles, what we do is that we use the same formula like we used in the starting question for today. We multiply concentration with volume, and usually since the volume is in cubic centimeters, as we use very small volumes in lab, it is divided by 1000. So this should be easy for NaOH because the concentration is what? 0.1. The volume is 25 cubic centimeter. Dividing it by 1000, you'd get your answer. And the answer is
So the answer is
2.5 into 10 raised to the power minus 3 or minus 4. I guess it's minus 3.
-3.
Right. Minus 3. Okay. For
Yes,
the
sir, it's
final,
-3. Yes, sir. 2.5 multiplied with 10 to the power.
great. It's 2.5 into 10 raised to the power minus 3. So for the second step, we usually tend to take the ratio. So the ratio would be of NaOH on one end, course, the left side. The right side would be HCl. Since we don't know about HCl, we need to find that out, and we already know everything about NaOH. So since this is 1:1, this should be easy. 2.5 into 10 raised to the power minus 3 x, and that means x is equal to 2.5 into 10 raised to the power minus 3. The same, since the ratio up top has the same numbers. So this one should be easy. 2.5 into 10 raised to the power minus 3. The book tends to do that out of words, but if we do it with the mathematical process, the ratio process, this should be easier for you to follow, right? Is it? Okay. So there is then the last step, concentration, and we already know that concentration is equal to moles over volume. And since the volume is in cubic centimeter, so we need to divide it by 1000 first. So really, in this case, it's going to be 2.5 multiplied by 10 raised to power minus 3 over 20, which is supposed to be divided by 1000. There you go. What's the answer to this one?
Sir, the answer is 0.125. Sir, could you explain this part again?
Part 3 or part 4?
Yes,
Oh,
part three,
part
sir.
2. Part
That's
3.
it, part
So
three.
I'm using the same formula as of part 1. I just rearranged it. See, there's concentration, there's mole. If you want to take the volume, you need to take the towards the other side as the denominator for moles. So concentration is equal to moles over volume. But the volume is in cubic centimeters, so we need an interconversion factor that is 1000, since 1 decimeter cube is equal to 1000 cubic centimeter.
Uh, Oh, so moles is given, we have the volume and the thousand, but the concentration we have to find. So we'll rearrange the formula.
Right, right. We just rearranged the formula. So it's 0.125 mole per decimeter cube. That's about it. This completes it.
So it's the same thing, just the yeah, this new, it's almost just got your message.
All right, great. So what I'm going to do is that I'm just going to write a couple of questions and you can actually take them as homework.
Okay.
So 0.125 mole per decimeter cube, 25 cubic centimeter, which is 4 was reacted. Actually, I shouldn't be using the word reacted. I should be using the word titrated. So titrated completely against 0.5 cubic centimeter KOH half. That's the equation in which you react H2SO4 with 2 KOH to form K2SO4 along with 2 moles of water. This is question number 1. Now, the question number 2 is exactly similar to what we did in question number 1. I'm not writing the steps, but I hope you can come out with the steps on your own. The first would be moles for H2SO4, then moles for KOH, and then finally the concentration for KOH. Okay, if that's fine with you.
Um, so could you repeat what you said?
What if I don't write the parts below, like step 1, step 2, step 3? Would you be
Um,
able to come up with those steps on your own?
yes, yes.
Okay, great. Then let's go with question number 3. So 0.13 mole per decimeter, 134 mole per decimeter cube HNO3 and 0.128 mole per decimeter cube of CaOH twice, commonly known as lime water, but the correct name would be calcium hydroxide, were completely titrated against each other as, and this is the equation, calcium hydroxide 1 mole when reacted with 2 moles of HNO3 give us 1 mole of calcium nitrate CaNO3 twice and gives us 2 moles of water. So 10 cubic centimeter of COH twice was used. Find out volume, and I'm going to specify in cubic centimeters of HNO3 used. Now this time, instead of finding the concentration in the third part for this question, you are going to find out the volume. So you'll need to just rearrange the formula a little bit, and that's about it. Okay. So there is a slight
Okay,
change,
sir.
a very small change in just the last part of question number 3. But for the rest of these two questions, they're exactly going to be the same. All right.
Okay, sir.
Um,